Good morning, everyone. Today, we're going to continue our discussion on multiple linear regression, in particular, making use of the LM function that comes with R. Okay, so this is the folder that I created, which contains the R project, multiple linear regression. So it's inside this folder uh, under FINTSAR master, and then under this folder, the project folder, multiple linear regression. Now, it's always good to save your files here, the files that I'm using for multiple linear regression. So here I have the data file on Excel. I have a history file. I have this RMD file on intro. I have this multiple linear regression file, RMD file, and the R projects file. The question is, which do you open? Oftentimes, it's best to open the R project, because if you open just one RMD, then that RMD will be the only one that will be opened. If I open the R project itself, so let me illustrate to you. If I open this, notice that this is an R project file. I click this. So it's opening now. I have another R project opened here. So the good thing about this is that you can open several projects. Okay, let me just close this. I was working on another file, a research file. Okay, now I have two here. Let me close one. Okay. So I open the R project, and you can see here that this is the R project multiple linear regression. It's inside the directory FINTSAR master. And if I go to files here, you can see here that we have here the different files inside that R project. Okay, and I can open one of them. This is the file that we were using last time, multiple linear regression May 9. Okay, so this is the file that we're looking at. Okay, so please chat in the chat box if you have opened the R project and the file itself. I don't know how you named the file, but in my case, it's multiple linear regression May 9. It will depend on how you open the file. So may I request you to please chat in the chat box if you have the file ready. Okay, good. Thank you. Okay, thank you for your feedback. Thank you for your comments. Okay, so we're now going to continue with our discussion here. Okay, so last time we said that the formula, okay, the formula for the intercept and, okay, where is that? This is the formula for the slope coefficient for a simple linear regression model. Okay, this is your beta 1. Okay, we wrote this in LaTeX. Okay, for now, we're not going to really look into the nitty-gritty details of a LaTeX code. Okay, but it's good for you to know this. Okay, you can see here that it's a lot easier to write an equation in LaTeX as compared to using a, let's say, the insert function in Excel. Medyo mahirap yun. Okay, here, just start with $2, $sign, $2 signs, then write the code inside that, and then it will be able to generate this equation. Okay, so you can see here slash hat slash beta underscore 1. That represents this one. Okay, slash hat, it's this hat symbol, and we said that the hat symbol pertains to the predicted value. Slash beta underscore 1, the underscore 1 is the subscript. Okay, and then how about this? Take a look at this. This is slash frac. This is for fraction. Okay, so that will generate this line here. Okay, so what's in the numerator? In the numerator, you have this, okay, curly brackets. You have here slash sum. Okay, so this will generate this one, slash sum, and then you identify the limits, slash limits, underscore I is equal to 1 in curly brackets, and then up to n. Okay, so you can see here that this one, okay, slash sum, it's this one, okay, and then slash limits, that will be the lower limit, I is equal to 1, and then the upper limit is n, okay? And then what's next? Inside that is, because this is the Riemann sum symbol, and then we have, again, curly brackets, x sub I, okay, x underscore I, that's your x subscript I, minus, and then we have, if it's now the bar here, it's slash bar. If it's the hat here, it's slash hat. So you can see that as you go along, as you gain more, let's say, expertise as far as LaTeX, LATEX, okay, when I say LaTeX formulation is concerned, it becomes really easy, and it's easy to really come up with an equation like this. So that's bar, that's x sub I minus bar x. So this is the one, okay? And then close parenthesis, which is this one, and then open parenthesis y sub I minus, once again, slash bar, okay, bar, and then y, bar y. Then close this, okay, and then close this expression, this whole expression that was open in curly brackets, you close it, and then you close the numerator. So this one, okay, this one is your numerator because it's expressed as a fraction. This one will now be the denominator. Okay, so numerator slash frac, you can write this as here, slash frac. This is your numerator. It ends in the curly brackets here. Okay, and then for the denominator, opens again with a curly bracket, and then this expression. Okay, this expression is again slash sum slash limits from I is equal to 1 to n. That takes care of this one. Okay, and then open parenthesis, what's inside the summation sum is x underscore I minus x bar of x, and then here is squared. Okay? And then close the curly brackets there. Okay, if I close this, and then if I enter, okay, put some space to it, there you go. Okay, so there are just, these are just rules that you need to follow in order to generate an equation like this. Okay, and it's really very handy. It's really very efficient in writing an equation like this, which can be very difficult if you're using another let's say program, another software. So in LaTeX, it's actually easy to use. Of course, there's a learning curve to it. But once you're able to overcome that learning curve, then it becomes a lot easier. Okay, I don't, of course, expect you to understand everything now, but as we go along, I hope that exposure, familiarity to the use of LaTeX will allow you to generate equations like this. Okay, so let me pause for a while and ask you for your feedback if it's okay so far. Okay, good, thank you. I gave this to you, right? I gave this this LaTeX formulation to you last time. And what we did was we first had our model, okay, our model, which is a linear model. We use the LM function, And the dependent variable is hourly wage regressed on education. So this is just a simple linear regression. Okay, it's called a simple linear regression because we only have one predictor. If we review our data, let me our data, because I closed this, our environment, my environment now is empty. I will have to run. So let me let me run the packages that we're going to use, the psych, hmis, broom, tidyverse, etc. And what we learned last time is that even if we haven't installed this, you can automatically install this by using the p underscore load function coming from pacman. Okay. And of course, you have to install first and load pacman and then run this. So I'm going to run this, control enter. So you notice I ran this and I did it at the end of the line here, or I can do it at the beginning, or I can have my active cursor at the middle, no problem. Okay. And then this is the function that I used, pload. And this pload comes from the pacman package. So in order, you can of course run it this way. You can just delete this pacman, then double colon here, and then pload. Okay, but for introductory purposes, for us to be able to know or to be reminded that this p underscore load, this pacman load is coming from this package, pacman. And of course, as we go along, then this becomes second nature to you. You don't have to put pacman here, okay? Because R will understand that the p underscore load is from this package, unless there's another function called p underscore load that comes from another package. So in that case, then this becomes very important because we're identifying where this package is coming from, yung p underscore load. Okay, if there's a conflict between that p underscore load coming from another package, then R will tell us. Okay, so in order to avoid that confusion, you just put the namespace here. Okay, pacman, then R will automatically know, okay, this is from the payload here comes from the pacman package. All right, so several packages here, some of which we're going to use later on. Okay, for example, Stargazer allows us to generate uh, tables, tables of the outputs. For example, we have several regression models, and you want to have a side-by-side printout of the different models, then Stargazer comes in very handy. Of course, later on, we'll know that Stargazer has its own limitations because it cannot do a panel linear model unless you convert first the models that you created into a linear model. So this has its limitations, and we have to use another type of another package. All right. So just to load the data that we used last time, the data I provided you is a CSV file, okay, wage.csv. Okay, so since the data is already inside the R project, then the code in order to access this data becomes really very easy. Unlike if this wage data was outside, it was in another folder, then the code will be quite long because you will have to identify yung file location yan, the file location of the folder. So it makes sense really to put your data inside the R project. And you can see here that our code here is just read underscore CSV, okay? And we identify the data, then column underscore names is equal to true, which means that this data has column names. All right, and then I created an object called wage to to be the name of this data that I'm loading. All right, so let me run this first, and automatically we can see here that okay, now there's an object here, wage, consisting of 526 observations of 8 variables. So we are sure that this is a data frame, okay, and automatically when we use this read underscore CSV, it gives us details already. Okay, so it tells us that the delimiter is a comma. That's why it's a CSV file consisting of 526 rows and 8 columns. Okay, there are 3 character variables here: race, gender, and civil status. And there are 5 that are quantitative double. Okay, if you recall double class, education, experience, tenure, number of dependents, hourly wage. Okay, all right. So if I want to view this, we can use the view wage function, or I can click this in the data. If I click this, notice that in the console, it will show view wage. Okay, so let me do that here. So clicking this one is equivalent to writing this code view wage, and it will automatically give us the printout of the data. Okay, so education, experience, tenure, race, gender, civil status, number of dependents, and hourly wage. 3 of our data are character, okay, race, gender, civil status, and then 5 are numeric. Okay, we can formalize that by using the structure function, structure of wage, okay, and this results into this one. Okay, so it's a special table, okay, 526 by 8, special table or a data frame. So these are the different types, class of that data, but it's a data frame. And I hope you watch the videos on data structure, because a data frame uh, has its characteristics that make it very good. And in fact, you cannot use a list when you do LM, the linear model. It has to be a data frame. So here, the dollar here indicates that you can only access this variable education via our wage. Okay, so wage dollar education. That's how you can access education. In fact, let's just point that out. So if I get the average of education, you won't be able to get it. Okay, it will return an error, okay, an error message, because R does not recognize the object education. So if I do, okay, mean of wage, and then I type the dollar sign, notice that automatically it's like an IntelliSense. It will tell us what's inside wage. Okay, wage dollar. Okay, so let me uh, press tab. Okay, and I get the average of education, and I get 12.56. All right, so these are simple things that we need to master, we need to know. All right. So the function summary will give us the 6 number summaries: the first quartile, second quartile, third quartile, minimum, maximum, and also the average. So if I get the summary of wage, it will yield into this. Okay. So education has a minimum value of 0, maximum of 18, first quartile, second quartile, which is the median, and then the third quartile. Okay, and then you notice that the median and the mean are not equivalent, so they're not, this education most probably is not normally distributed. And so, of course, also with experience, with tenure, notice that their medians are quite far off from the mean. Okay, and we said that a approximately normally distributed data is when your mean and your median are very close to each other. Okay, so for character variables, okay, there is no such thing as first quartile, second quartile, etc. So you can only get the count, okay, the length, which is the count, or the type character. So that's for this one. Okay, once again, let me pause for a while and ask for your feedback if we're going okay, clear ba tayo, or am I going too fast? Okay, good. Thank you. Thank you. So at any time in my discussion, please feel free to interrupt me and raise a question. Okay, I'll really appreciate that. Okay, because this is actually not a sprint. As I said, this is a marathon. We're here together up to August pa tayo, no? So let's not let's support each other in this learning journey. Okay.
Can I see can we see the Previous code po.
Previous code? Oh, sige.
Thank you.
You mean to say this one? Which one?
Yung sa correlation plot po.
A correlation plot. Okay.
Thank you.
Okay. We'll review this. We actually discussed this last time. And coming from the site package, okay, there's a function called pairs.panels. Okay, so this will create a correlation matrix between your variables in the wage data set. So if you run this, control enter, okay, it will create a correlation matrix plot. There you go. Okay. Some of which might not be useful to us because uh, the this one, gender, civil status, and race. Okay. Notice their distribution. Binary siya, di ba? Race is white or non-white to, no? For gender, male, female. For civil status, it's married and single. Notice that although it gives us a correlation measure, okay, so for race, it's 0.01. So what is this 0.01 about? You go here, and then you pair race with gender. Okay, it's negative 0.01. However, we know that a character variable does not technically have a correlation between themselves. Whether it's let's say, a character variable and the numeric, or character and character variable. There is no practical correlation with them. Okay, unless, now for this one, for example, race, and this one is, let's go to race, and this is hourly wage. So go to this value here, 0.04. What's this value? It's an intersection of this. On the horizontal axis is your race, and on the vertical axis is your hourly wage. And there's a value 0.04. Now, it only generates a value because there's a transformation that was created. The value of race is white and non-white. So apparently what was done here was to convert white into either 0 or 1, and then non-white into a 0 or 1. So because of that, there was generated some values, numerical values. And from there, the correlation was computed, okay, with hourly wage. But as we said, this artificial transformation is of no use to us. Kasi there's no correlation if it's a character variable, non-quantitative variable. So instead of generating this, okay, let me close this. What we can do is, okay, let's remove, let me, let's remove those variables that are character. Okay, so take a look at this. How is this done? I'm creating this object called wage1, and it's coming from the wage data set. And then you notice here the brackets here. The square brackets stand for subsetting. Okay, the first element here is a rows. So which means that untouched rows, which means that we're not subsetting it. The wage data set has 526 rows of observations, which means that everything will be included when we create that object wage1. What will be subsetted is, notice here, negative C. C stands for concatenate. Negative C stands for remove. Okay, remove 4 to 6. What's 4 to 6? Columns 1, 2, 3, 4, 5, 6 is your race, gender, and civil status. So those are your variables that are quantitative. So we're subtracting it, negative C. Or another way to do this, there are several ways to do this. Okay, control C, control V. So let me just use, for example, wage 2. And then instead of removing, I'm going to include C. Okay, 1 up to 3, and then 7 up to 8. Am I correct? 7 to 8. 1, 2, 3, correct? 4, 5, 6, 7, and then 8. Okay, so that's this is another way to do it, class. Instead of the negative C, you have the positive C. And then you're combining the first to third columns, first three columns, and then seventh and eighth column. It's equivalent to this one. Okay, so let's just be aware that there are several ways to do this. Okay, this is one of them, and this is another one. So I'm just going to create wage one, which excludes, which removes, okay, fourth up to sixth column. If I enter this, control enter, okay, and here under the environment window, I now have this object wage one. And if I print this view, okay, let's see, view wage one, and then you can see here that it only includes those variables that are quantitative. Okay, so when you're creating a correlation matrix, it's best to just include the quantitative variables. Okay, and here, same thing, we can use the pairs.panels function from site, or I'll just run this. There's another way to create a correlation matrix. We can use the GG pairs function. This is coming from GG ally. Okay, grammar of graphics ally, GG pairs. So wage one, okay, let's run this, control enter. And we have, for me, it's a better way to present your correlation matrix. Okay, there, okay, here. Let's see if this can be maximized. Okay. All right. So you can see here, for me, it's a better presentation of your correlation matrix. Here you have, on the diagonals, you have the plot of the variable itself. Education, experience, tenure. This is number of dependents, and this is hourly wage. From the univariate plot, you can see that education seems to be the closest to a normal distribution. Experience is, okay, it's going down. Okay, tenure also has this plot, number of dependents, and hourly wage is also quite similar to a normal distribution. Okay, so of this five, you can see here that education and correlation seems to be the distribution, the data that are close to a normal distribution. Okay, so what is this one? These ones are the scatter plot. Okay, scatter plot of your in this case, education, okay, is on the x-axis, and experience is on the y-axis. So you can see here the scatter plot of education with experience. Okay, and education with experience, this one, their correlation is education, experience. Their correlation is negative 0.3. Okay, so they are negatively correlated, which means that as education goes up, experience goes down, or vice versa. As experience goes down or goes up, education goes down. The value of education goes down. Okay, and this is the scatter plot. Then also, so all of this in the upper diagonals are the correlation between the variables. Now, in our case, we're studying the effect of education, experience, tenure, number of dependents, and on hourly wage. So we want that the independent variables, which are education, experience, tenure, and number of dependents, we want them to have high correlation between them and hourly wage. Why is that so? Because we're using this as predictors. Okay, and as a predictor, okay, it will be good, okay, for that independent variable to have a high correlation with the dependent variable. Okay, and then so we can see here that in terms of correlation with hourly wage, education has the highest correlation. okay, followed by tenure, okay, followed by experience, and then lastly, number of dependents. So if you're just going to choose one among this one, then education seems to be the best guess, okay, because it has the highest correlation with hourly wage. If you're going to choose two, then the next one should be tenure. Three, then it should be experience. Number of dependents seem to be the least correlated with your hourly wage. Okay. All right. Pause first. So far, class, clear ba tong correlation matrix natin, which is our GG pairs of wage 1? I request your feedback if we're okay so far. Okay, good. Thank you. Okay, good. Thank you, everyone. I hope I'm not going too fast. If I'm going too fast on a particular topic, please interrupt me and tell me what you wish me to repeat. All right. So what we did last time was to create a simple linear regression model. Okay. And based on this one, it seems that the correlation with education is the highest. So we're going to just use education in trying to predict hourly wage. Of course, we can use the other variables like experience and tenure. However, it might not give us a good result. Okay, so let's plot. We can use the plot function. Okay, I want to plot education on the x-axis and hourly wage on the y-axis. So the first one here is your x-axis. The second one is your y-axis. And usually the independent variables are the one plotted on the x-axis. Okay, and then just give it a name, scatter plot of education and hourly wage. Okay, when we run this last time, we saw that, okay, so this is the relationship between education and hourly wage, okay, which we saw already here. Okay, this one. Education and hourly wage. So this is the one. Okay, education, hourly wage. Okay, this is the scatter plot, and this plot looks very much like this one. Okay, so we just isolated this plot. Okay, and we can see here that if we're going to use education as a predictor, mukhang positive yung ano, no? Correlation, positive yung correlation niya, no? And we saw that here, the correlation. Here, the correlation is 0.4. It's positively correlated. All right, then moving on, class, now to the modeling itself. We create this object mod1 and use the LM function, linear model function. Okay, this is the tour de force of linear regression in R. You use the LM function, you define the dependent variable, and then define the independent variable. So here, we're just using one variable. So this is a simple linear regression, and define data. Now notice that I did not anymore put wage dollar hourly wage here or wage dollar education because we're specifically adding what data this is coming from. The data is wage. All right, and we ran this last time very quickly, quick review, no? And this is the result. It looks like any normal regression model that you used in your prior subjects. You have here the estimate, okay, the value of your intercept. This is your standard error. This is your t-value. This is your p-value. Okay, and then we're going to look at the details of this, greater detail in the future. Okay, for now, let's just very quickly, how do we interpret this? Okay, for example, this one, intercept. Okay, this is the standard error. It's like the standard deviation of your variable. And then the t-value here is just your beta sub I, this is our beta sub I, divided by your standard error. Okay, so negative 0.9 divided by 0.68 is your negative 1.321. And why is this needed? Because we will have to use this p-value in order to determine the p-value. Okay, so actually we can create inferences already without the p-value here, just basing on the t-value, which we're going to discuss in the future. All right, so what's the interpretation here? What's the meaning of this one? So the meaning of this one is that, okay, remember the dependent variable here is hourly wage. This is what we're predicting. Hourly wage is our dependent variable. So this means that this is the average value of your hourly wage when all your predictors are equal to 0. So that means that this is the average hourly wage when the respondents have 0 years of education. Because we're going to delete this out. How do we delete this out? Let education be equal to 0. So 0 years of education. So for a person who has 0 years of education, the average hourly wage is negative 0.90405. Of course, that doesn't make sense, because how can somebody be getting a negative 0.9 hourly wage? So that indicates that the person is going to pay the company, diba? Kung negative yung hourly wage, hindi naman pa pwede yun. There's no such thing. However, class, although the intercept might have a twisted interpretation, we still include this in our model, and I'm going to show you how. Okay, so for the education, this is our beta 1. This is our beta null. Our intercept is always called beta null. The first parameter, the first predictor, beta 1, has an estimate of 0.54, standard error of 0.05. If you divide the estimate by the standard error, then you get a t-value of 10.167. And here, okay, the p-value is 2e to the negative 16. What does this mean? Okay, it means that, okay, what's important here is not really the value here, but this one. Okay, because this is already an estimate. What's important is this one. So what does this one mean? Okay, take a look at this. For R, the significant codes are, okay, for 0, none. For 0.01, 3 stars. For 2 stars, it's significant at 1%. For 1 star, significant at 5%. And if you see a dot, it's significant at 10%. And no symbol, okay, for 0 and 1. Now, education has 3 stars. This one. So it means that this parameter, education, is significant at the 0.001 level of significance, or 0.1% level of significance. So it's highly significant. Okay. On the other hand, intercept, notice it has no star, it has no dot, which means this is not significant. Okay, empty siya. 0.187, the p-value. Okay, so the decision rule is that you have to take a look at the p-value, and the rule is when the p is low. So remember this: when the p is low, the null must go. Okay, so let me explain this. When the p is low, the null must go. So this presupposes that this one is the result of a statistical test. And for a statistical test, there has to be a null hypothesis. So let's take a look at the null hypothesis for the intercept. The null hypothesis there is, write it here. I'll write null hypothesis. It's that beta null, that's for the intercept, is equal to 0. And of course, the alternative hypothesis is beta null is not equal to 0. Okay, so what does this indicate? So we're testing this if the intercept is equal to 0. And then you have a p-value that's 0.187, which is greater than the usual alpha is the level of significance is 0.05. Okay, that's the usual uh, level of significance that's used. So you can see here that the p-value, okay, the p-value is 0.187, which is greater than. Let's assume that the level of significance is 0.055%. So this is greater than 0.05. So what's our conclusion? Okay, the rule is when the p is low, the null must go. When you say low, it means less than 0.05. Okay, it's less than 0.05. Now, if you take a look at the p here, it's 0.187. So it's not low relatively. So the p is greater than 0.05. Therefore, okay, what's our conclusion? We cannot reject the null hypothesis. The null must go means we reject the null hypothesis. So we fail to reject the null hypothesis that your beta null is equal to 0. So that's the inference there. Okay, since the p-value is 0.187 and it's greater than the standard of 0.05, then the conclusion is, okay, we do not say we accept the null hypothesis. No, this statistical test aimed to determine if there's reason to believe if the beta null is equal to 0. We were not proving that beta null is not equal to 0. That's why we do not accept the null hypothesis. Okay? So we're just saying that we didn't find enough evidence to show that beta null is equal to 0. So we fail to reject the null hypothesis that beta null is equal to 0. Okay, I hope that's clear, class, because I've seen students say, we accept the null hypothesis. Hindi natin ina-accept yung null hypothesis. Ang pinoprove natin, class, what we're trying to prove is if there's strong statistical reason to believe that beta null is equal to 0. Okay, so we're saying that the intercept is 0. Okay, in this case, we said that no, since the p-value is not low, then the conclusion is we fail to reject the null hypothesis that the beta null is 0. Okay, so there's strong reason to believe that indeed, there's strong reason to believe that beta null, okay, since we're failing to reject this, there's strong reason to believe that beta null is equal to 0. Okay, so that's what this means. Okay, and then for the parameter education, the value is 0.54. Okay, standard error is 0.05. P-value is generated by dividing this. And then the p-value is generated by looking this up in the table. And then you can see here that the p-value is practically 0. Okay, so 3 stars, dito siya. Significant at 0.001, which means that the p-value is less than 0.001. It's less than 0.05, it's less than 0.01, and it's even less than 0.001. So highly significant. All right. So what's our null hypothesis here? Our null hypothesis is that beta null is equal to 0. And what's our inference? Our inference is we reject the null hypothesis that beta 1 is equal to 0. Okay, we reject this. Why? The p-value is low. It's less than 0.05. Hence, the null must go. Our null hypothesis is that beta 1 is equal to 0. So that must go. We reject this null hypothesis. So what's the meaning of this? The average value of education is 0.54. Okay, and how do we interpret this? This one is the marginal effect, okay, of education on the dependent variable hourly wage. It's the marginal effect. So what does that mean? This means that for every 1 year increase in education, why am I saying that? Because the dimension of education is in years. Yeah, we just have to follow the dimension of the data. for every 1 year increase in education, there's a corresponding 54 centavos, dollars, no? 0.54 dollars in your hourly wage, and then you include ceteris paribus. Okay, let me repeat that. For every 1 year increase in education. Okay, 1 year increase in education. Why? Because education is the parameter that we're testing. Okay, and based on the statistical test, it's significant at 0.001. Okay, the 3 stars there. And it tells us that we have to reject the null hypothesis that that education is equal to 0. Education is not equal to 0. It means that it has an impact on hourly wage. And what's that? For every 1 year increase in education, there's a corresponding dollar, 0.54. Why dollar 0.54? Because hourly wage is in dollars. Okay, so that's how we will interpret this. There's a corresponding $0.54 increase in hourly wage, and then we have to put here ceteris paribus. So what's the meaning of ceteris paribus? Ceteris paribus means all things being equal. What's the meaning of that? All things being equal. It means that you're only going to increase education by 1 unit. Okay? So we said that for every 1 year increase in education, there's a corresponding $0.54 increase in hourly wage, ceteris paribus. It means that all the other variables should not be increased. They remain constant. Okay, what we're only increasing is education. All right, so pause for a while. And let me ask you, class, if are there any questions? Paki-chat naman, please. Kindly chat if the discussion is clear so far. Okay, good. Thank you.
Sir, question po pala.
Sure, go.
Sir, bakit po yung significant level na ginamit dun sa intercept is 0.5 pala?
0.5. 0.05, ha?
0.05 po pala.
Mm-mm.
Bakit po 0.05?
Sorry, what's the question again? Why ano?
Sir, bakit po 0.05 yung ginamit?
Okay. It's a
Na
standard, no? It's a standard that ang ibig sabihin actually niyan, how low are we willing to come up with a conclusion na na zero nga yung intercept natin. And it's a standard that has been used. Whether usually sa econometrics, sa finance, ang standard na ginagamit is 0.05. It means that willing tayo na maging mali na 0.5 5% of the time. Okay? For other fields, baka mas kailangan nila mas mataas, no? Na confidence level. For example, sa mga statistical test on that involve medicine, yung mga medical sciences, gumagamit sila ng mas mataas na confidence level. Okay, kasi kunyari, magkamali sila dun sa inference nila. They don't want a high level of significance level. Ayaw nila ng ganun. Kunyari, ang gagawin nilang level of significance is 10%. So that means that they're willing to be wrong 10% of the time. So ang level of confidence level nila is 90%. Sa econometrics, okay lang na ang confidence level is 95%. Confidence level of 95% means that your level of significance is 5%. Ibig sabihin nun, na willing tayo na maging wrong 5% of the time. Kasi hindi naman matter of life and death yung naaral sa econometrics. Okay? So, it's a standard that has been used, Jared. No? So, unless there's a compelling reason to make the level of significance lower, which means that the level of confidence is higher, then we will still maintain the 0.05 level of significance. Okay? Now, yung 0.05 niyan, para sa lahat ng parameters yan, ha? Okay? Hindi lang para sa intercept yan. Para sa education yan, para sa lahat ng parameters na ine-estimate natin. We're testing it. We're testing whether the betas, the parameters, the estimates are all equal to 0, given a level of significance of 5%. Okay? Jared, did that answer your question?
Wait, sir. So akala ko po doon sa education ang ginamit is yung 0.001 since
Yeah.
may tatlong
0.05 pa
stars.
rin. 0.05, no? So ito, without looking at the 3 stars, no? We're saying that education is significant pa rin at 0.05. So if it's significant at 0.001, obviously it will be significant at 0.05. Kasi mas mababang level of mas maano to eh. Mas ang level of significance niya mas mababa. So we're saying here that the confidence level is 99.9%. Okay, 99.9% tayo sigurado na ang value ng education is not equal to 0. Yun ang sinasabi diyan. We are also sure 99% using the 0.01 level of significance, which is 1%, we're 99% certain that education is not equal to 0. Ito naman, we are 95% certain that education is not equal to 0. Okay? Now, all of those are true. No? Whether it's 99.9% significance, confidence, that education is not equal to 0, totoo yun. Or 99% confident tayo that education is not 0, totoo din yun. Or 95% confident tayo that education is not equal to 0, totoo din yun. Why? Because the p-value is so small. Diba? If you compare yung p-value natin, so that's actually technically, but I'll tell you later on na hindi naman siya talaga eksaktong 2e to the negative 16. Anong ibig sabihin nito? So isulat natin 2, and then you go to the left. Ulan to. You go to the left, no? Here. 16 times. 1, 2, 3, 4, 5, 6, 7, 8. Hanggang 16 na zeros. That, so 16, bali, 15 na zero siya, and then 2. So ano yung ibig sabihin nito? This is the probability that yung education will be equal to 0. Napakaliit na probability niyan. Di ba? 2e to the negative 16. What's the probability that education will be equal to 0? Ito, 2e to the negative 16. Okay, therefore, anong conclusion natin? Practically, we're saying that education is not equal to 0. Okay, there's a very, 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 very small possibility that education is not equal to 0. Okay, so this caused the confusion kanina. No? Itong 3 stars. Itong 3 stars, ang sinasabi lang yan, na kahit gumamit pa tayo ng 99.9% confidence level, i-reject pa rin natin itong education na equal to 0 yan. Or gagamit tayo ng 99.99% confidence level, which is the same as using a 1% significance level. Okay, anong conclusion natin? Reject pa rin yung null hypothesis natin na equal to 0 yan. Okay? Bakit? Kasi yung probability na magiging 0 siya is this one. Okay. Ano mas malaki? Yung 0.001 o itong 0.0002? Okay, ano mas maliit? Siyempre ito, di ba? So we're saying that this one is much less than 0.001. This one is much less than 0.01. This one is much less than 0.05. Diba? Now, if this is much less than 0.001, obviously, it will be much less than 0.05. Ganun na rin yun. Diba? So again, the 3 stars here only indicate that if we were using a 99.9% level of confidence, then i-reject natin to null hypothesis na to. Okay? Pero, ano yung ginagamit na significance level? dito sa test na to, 0.05. Okay? But if we were using 99.9%, are we going to reject this null hypothesis? Reject. If we were using 99.99% confidence level or 1% level of significance, are we going to reject this null hypothesis? Yes, reject pa rin. If we're going to use a 5% level of significance or a 95% confidence level, are we going to reject this null hypothesis? Yes, reject pa rin. Bakit? Kasi tinitingnan natin yung probability, no? Na probability na magiging zero siya. And it's 0.00000000, 15 zeros and then 2. Yun ang probability na si education ay magiging zero. Okay, anong rule natin? You compare the p-value. The p-value and the level of significance. So if we were using a level of significance na 0.05, anong conclusion? The p is low. I-compare mo yung 0.002, etc. kay 0.05. Low ba si p? Yes, low si p. Therefore, the null hypothesis, which is beta is equal to 0, must go. Reject natin yan. What about using 0.01? Compare natin itong 0.000002 with 0.01. Is p lower than 0.01? Yes. Therefore, conclusion, the null must go. Ano yung null must go? That the beta 1 is equal to 0. Okay, compare natin. If we're using a significance level of 0.01, okay? Compare mo si p with 0.001. Mas mababa ba si p? Yes. The p is low. Therefore, the null must go. So, ang sinasabi lang nito, whether we're using a 5% significance level or a 0.01, 1% significance level or a 0.1 significance level, still, conclusion natin, reject the null hypothesis that beta 1 is equal to 0. Okay? So actually, Jared, it doesn't matter whether it's 3 stars or 2 stars or just 1 star. Okay? It doesn't matter. Ang importante doon, ang benchmark na ginamit natin, 5%. So, if it's 1 star, still reject, pareho pa rin conclusion natin. Reject pa rin natin null hypothesis na beta 1 is equal to 0. Okay? Jared? Sorry for the,
Yes, sir.
for the long
Yes, sir.
explanation.
Thank you po.
Oh, but
Gets
thank
na
you.
po,
Thank
gets
you so much. That's a very good question. I really appreciate that. Okay, everyone, nakuha ba yun yung ano, yung that was a very important question posed by Jared. Ang leading to some sort of a confusion dun sa 3 stars, no? Okay, ito nagsasabi lang na very significant yung ano natin. 3 stars, ibig sabihin, if you're going to compare the p-value with 0.001, then way lower yung ano natin, p-value. So napaka-strong ng rejection natin ng null hypothesis. Okay? Sige, i-ano ko muna to i-clear ko muna yung drawings, tapos X dito. Okay? And then let me see. Okay, thank you. Thank you for the feedback na clear. All right. So we discussed ano ibig sabihin ng ano ibig sabihin ng education na to, okay? Ano ibig sabihin ng parameter na yan? Okay? Pareho lang yan, class. Magiging discussion natin kung meron tayong several variables. Ganon din yun. We're going to look at one by one. All right. Meron pa tayo dito, no? Ito. Meron tayong residual standard error, meron tayong degrees of freedom, okay? Meron tayong multiple R squared, adjusted R squared, F statistic, okay? On 1, 524, and p-value. Now, all of this have to be understood by us. Hindi pa pwedeng nagkaroon tayo ng regression output kasi hindi natin naiintindihan kung ano yung ibig sabihin nito. No? Okay, so quickly lang, okay? Sasabihin natin, ano tong residual standard error? Okay, isipin niyo yung standard deviation class, no? Parang standard deviation lang yan ng mga error terms. Okay? So paano ba nakukuha yan? 'Di ba? Kasi meron tayong actual value ni Y. Si Y, si hourly wage to. Tapos meron tayong predicted value. Okay? Meron tayong predicted value ni Y. Paano makukuha yung predicted value ni Y? Ito. Gagamitin tong equation na to. Na hourly wage, I'll just write Y sub I predicted is equal to the intercept negative 0.90485 plus 0.54136 times your education. Okay? Notice that I'm not putting an error term here kasi naka-hat tayo dito, ibig sabihin predicted to. If I'm going to remove this. Okay? And so ito yung ano, yung predicted value natin. So hindi siya equal dun sa actual value. So paano siya maging equal? Kailangan lalagyan natin ng epsilon to account for the difference between your predicted value and your actual value. Okay? So we're going to discuss this later in greater detail sa multiple linear regression. Now, ano tong 524 degrees of freedom? Okay, ilan yung observations natin? How many observations? We have n, which is 526, di ba? Okay, n minus k minus 1. This is the formula to compute for your degrees of freedom. Okay, what's your n? The number of observations, 526. What's k? K is the number of predictors. Ano yung predictor natin? Isa lang, education lang. Kung dalawa yung predictor natin, so yung k natin 2. So dito, since 1 lang siya, minus 1. And then may minus 1 dito. Minus 1. What's this minus 1 for? This minus 1 is to account for the degree of freedom lost for the intercept. Kasi mawawalan tayo ng degree of freedom pag ine-estimate natin si intercept. So lagi may minus 1 yan. Unless hindi natin ipapasolve si intercept. Okay? Therefore, the degrees of freedom is 524. 526 minus 1, that's 524. All right? Then we have multiple r squared and adjusted r squared. I'll be discussing this in greater detail. It only means that, kunyari itong 16.48% na yan. Ano ibig sabihin yan? Ibig sabihin yan that the model, okay, can explain 16.48% of the variation of the variability of your hourly wage. Think of it this way. Ito si hourly wage, no? Si hourly wage ito. Si hourly wage, may variation yan. The data varies. No? Tapos, ginamit natin si education para i-predict si hourly wage. Ang sinasabi nito that si education, it can account for 16.48%. Ang kayang i-explain ni education is 16.48% of the variability of your ito, no? So itong buong to, yung variation, yung variability ni hourly wage. The model, in particular, yung education natin, can account for 16.48% of the variation of the hourly wage. Okay? So if we're going to use this model, then kaya nating i-account, i-explain 16.48% of the variability of hourly wage. How about the rest? Hindi kaya explain. Then most probably yung 83% na yan can be explained by other variables. Okay? All right. So lastly, you have F statistics. Ito, class, diniscuss na to dati sa ANOVA, analysis of variance. This one, class, is a test of means, individual t-test to. Okay, individual kasi may sarili-sarili silang null hypothesis. Ito, beta null natin is equal to 0. Ito, beta 1 natin is equal to 0. So we're testing if the intercept is equal to 0. Okay, and we're testing if education is equal to 0. And we came up with these conclusions based on the p-value. Yung ANOVA naman, class, ito. It's the analysis of variance test. And our null hypothesis here is, so this is your overall goodness of fit test, overall. So it's your beta null, sama-sama sila, is equal to beta 1 is equal to 0. For some, hindi na sinasama to intercept, no? Pero it's okay. So overall goodness of fit test to. Beta null is equal to beta 1 is equal to 0. And pag ANOVA class, kailangan ng dalawang degrees of freedom. Degree of freedom 1 and degree of freedom 2. Okay? Ano yung degree of freedom 1? Degree of freedom 1 is your ito yung sa intercept natin. 1. Ano yung degree of freedom 2? This is your, degree of freedom 1 will be your K, yung number of predictors. So ito, ang number of predictors natin, isa lang, di ba? Only 1. Ito naman, yung N minus K minus 1. Ito yun. N minus K minus 1, so 524. So you can see here that degree of freedom degree of freedom 1 is 1. Yung predictor natin, isa lang. Degree of freedom 2, N minus K minus 1. And then we have a p-value is practically the same as this one. So ano ibig sabihin nito? The p-value is very, very low. Therefore, we reject this null hypothesis. So ang inference natin dun sa ANOVA natin, reject the null hypothesis that beta null is equal to beta 1 is equal to 0. So there is a strong statistical reason to believe that at least one of this is not equal to 0. Kasi ito joint test, no? Pinagsasama natin. Kung marami tayong predictors, edi isasama natin lahat ng predictors yun. So yung tinetest natin kung lahat ng mga yon is equal to 0. Okay? So, okay. So let me pause for a while. I hope, of course, we're going to discuss this in greater detail. So for now, yun na munang intindihan natin. At least, naintindihan natin to, no? Hindi pa natin dinidiscuss yung adjusted R squared. But at least yung multiple R squared, no? Yung 16.48%, it means that our model, which is this one, yung model natin, y sub I is equal to negative 0.90 plus 0.054 times education, no? Okay, our model can explain 16.48% of the variation in our dependent variable hourly wage. Okay? So, ano yung kulang? 83%. Unexplained yun, unexplained variation. So, saan makukuha yun? Well, with other variables. So, there must be other variables that can be used in order to explain our predictor education. Okay, once again, pause class. I hope you're getting it, class. I know that this might be parang ang bilis kagad, ano, ang dami nating nakuha with this anatomy. So please, i-watch yung ulit yung video, no? Nobody's preventing. I'm going to post it. I was checking, akala ko na-post ko na yung last Monday, hindi pa pala. I'm going to post it together with this one. I'm sorry about that. Okay, paki-chat please kung okay tayo so far dun sa ano? Dun sa ano natin, sa unang model natin. Okay, good. Thank you so much. And good. Thank you. All right, then let's start with makapagsimula na tayo ng ano, ng multiple, no? Kasi ito parang review na lang to eh. Okay, I want us now to create a multiple linear regression model. So let's go now here. Okay, so I'm going to suspend for a while yung pag-compute ng standard error, pag-compute ng na-discuss natin yung pag-compute ng beta eh, ito. And kailangan natin malaman kung paano i-compute yung standard error. Medyo madugo yung formula niya, ito. Okay? Bakit natin kailangan computein si standard error? Para ma-compute natin si t-value. Yan. Okay. Bakit kailangan natin ma-compute si t-value? We need to compute for the t-value because it is where your inference will come from, whether to reject or not reject the null hypothesis. Okay. Sige, let me go here now. Okay. May question ba? Okay, clear. Thank you. Okay. So we'll skip that muna kasi class, ano yan eh, simple linear regression lang. Ang mas importante sa atin yung multiple linear regression. Okay, so let's go here now. Okay, I'm skipping a lot of things, but we're going to discuss that. Okay. Okay, now we'll go here, class. So in the interest of time, I'm going to share this with you. Control C. I'm going to share the code. Okay. So kindly copy that. Okay, now I'm suspending the discussion of the other details Why? Because those were details on simple linear regression. We will go back to that, but this time in the context of multiple linear regression. Kasi I realized that we're not really interested in the simple linear regression. Okay, we're more interested in is the multiple linear regression. Okay, kindly chat please if you have the copy of the code ready. You have the copy of the code. All right. Okay, good. Sige. Now, model number 2 is we're going to regress hourly wage on all the independent variables. So let's take a look at our data. Diba, ang data natin ito, education, experience, tenure, race, gender, civil status, number of dependents, and hourly wage. Now, take note that our data wage has 3 character variables. Okay? Has 3 categorical variables. Ang question, pwede bang gamitin yan sa linear regression? Yes, pwede siya. Kunin muna natin dito. I'm going to put it here, Control Alt I. Let's take a look at the structure of wage. Tinan ulit natin si wage data set natin. And sabi natin, di ba, yun, no? Si race, si gender, tsaka si civil status. Okay? They're character variables. Okay, pwede bang gamitin sila? Yes, pwede. Okay. So kapag multiple linear regression class, reminder lang, the dependent variable has to be numeric. Hindi siya pwedeng character variable. This is very important kasi sa first case nyo, okay, marami nagkakamali na ang pinipili nilang dependent variable is a character variable. Hindi pwede yun, ha? Pag if it's a multiple linear regression, okay, the dependent variable should be numeric. What about the independent variables? Anything goes, okay? So pwede siyang numeric, pwede siyang categorical. No problem. Okay? So how do we now create a linear regression? So I'm creating this object called mod2, model 2. Ganun din LM, hourly wage, tilde, okay? Between tilde, education, experience, tenure, race, gender, civil status, number of dependents, okay? So sinama ko na dito lahat ng predictors natin, yung 7 variables. And data is equal to wage. Okay? So you can write it this way, or you can write it this way. Ang shortcut, dito ko na ilalagay ito. Control X. Control V. And then I'm going to comment this out. So naglagay ako ng hashtag, ibig sabihin comment yan. No? Okay, so a faster way to write this is tilde and then dot. Ano ibig sabihin ng dot dito? This dot means that all the variables are included. So pag sinabing all the variables, syempre except yung hourly wage. So it's equivalent to this one. Okay? Alright, so for our purposes, gamitin natin itong completely spelled out para mas madali natin makita. No? So we're creating now this model number 2, and then we're regressing hourly wage on education, experience, tenure, race, gender, etc. Alright, I'm going to run this. I hope you run it too, please. Control Enter. Okay, so if we look at this now, meron tayong model number 2 dito. And si model number 1, yung simple linear regression, list of 12. Ito si model number 2, list of 13. Okay, I can click this para alam natin kung ano bang makikita natin dito. Ito, no, si model number 2, it's a list. So, take a look at this class. Andyan yung value ng coefficients. Okay? Andyan yung value ng residuals, effects, treated values, and dito. We'll discuss that in greater detail. Okay? So, suffice it to say now, class, that model number 2 is a list object, and it has many elements in it. Okay? So, if we can, let's use now summary to see what's inside model number 2. And here we go, the linear model output there. Now you can see that andito na lahat ng mga variables. No? Andito na lahat ng mga variables. Intercept, education, experience, tenure. Oops, pero something strange happens here. Meron tayong ito, race na white, gender na male, civil status na single. Okay, ano kaya yun? Ba't kaya ganun yun? Okay, balikan lang natin class yung ano table. I'm going to use the table function. Wage, $sign, okay? Raise. Okay, let's see. If I use the table, wage, $sign, raise, sino natin kung ano laman ito. So you notice that it includes non-white at saka white. So dalawang level siya, no? Non-white consists of 54 and white consists of 472. Let's copy this and see ano din laman ng iba. Control C, Control V, Control V. So this is race, dollar, then you have your gender, tab, and then this one, race, tanggalin dollar, itype mo yung dollar para lumabas yung mga choices, gender, and then civil status, tab. Yan, shortcut, no? And then let's run this all together. Control Enter. Okay, so we can see here what are the elements. Ano laman ito mga to? No? Non-white, white, female, male, and then married, single. Okay, so each of these character variables have two levels. Si race, non-white at saka sa white. Si female, si gender, female at saka si male. Si civil status, married at saka single. Okay. All right. So let's interpret first. Interpret natin ano? Ano to? Ano to lumalabas na to na? Let me run summary 2 ulit. Summary model 2. Okay. All right. So first, it's a call to the formula, di ba? Kinol ni R yung formula. Formula niya, hourly wage regress on this one. Tapos may summary siya ng mga residuals, no? Minimum residuals at saka maximum residuals. And then, dito na yung coefficients. All right, so we now have here the values of your parameters of your coefficients. Ito na yung individual t-test natin. Okay, first, education. Just like a while ago, significant siya. Si education din dito significant. Okay, so education, 0.5748, medyo naiba yung value kanina, no? Nung estimate. Standard error is 0.05, t-value is 11. P is practically the same kanina, significant at 0.001 or at 0.1%. Okay, so what does this mean? Okay, if we interpret this, sabi natin, for every 1 year increase in education, there's a corresponding $0.57 or 57.46 centavo cents increase in hourly wage. And then remember, ceteris paribus. Okay, always include ceteris paribus, which means all things being the same. So what are we saying here? If we increase education by 1 year, okay, hourly wage will increase by $0.574. And it's statistically significant, no? Kasi we are rejecting the null hypothesis beta 1 is equal to 0. So this is our test here for education, where the test is that the intercept, the parameter, the slope for education is 0. We reject this. We reject this. There's strong statistical reason to believe that for every 1 year increase in education, hourly wage increases by $0.57. Ceteris paribus. So when you say ceteris paribus, all things being the same, you do not increase experience, you do not increase tenure, you do not increase the others. Because if you increase tenure, baka magkakaroon din siya ng marginal effect kay hourly wage. Kasi ito may ano siya, no? And it's significant at 10%. Isang dot lang. So if we're going to be very strict with the level of significance, i-reject natin to. Kasi ito, it's not less than 0.05, 0.07. Significant siya if we were using the 10% level of significance or the 90% confidence level. Okay, so how about tenure class? Punta natin si experience. Let's assume that this is significant. Let's say kahit 1 star. How do we now interpret experience? For every 1 year increase in experience, but what year? Kasi Bakit year? Kasi experience is in terms of, ang dimension niya years. For every 1 year increase in experience, there's a corresponding 2 cents, $0.02 or 2 centavos, 2.2 centavos cents increase in hourly wage, ceteris paribus, assuming it's significant. How about tenure? For every 1 year, year din sa tenure For every 1 year increase in tenure, there's a corresponding approximately $0.14 increase in hourly wage, ceteris paribus. Okay? All right. So, it's almost time. Magbibigay lang ako ng isang example dito, class, no? Kasi very interesting tong si ano. Notice the number of dependents, no? Hindi siya significant. Okay? Not significant at even the 10%. And that was to be expected. If you recall, anong sabi natin kanina? Si number of dependents, yan ang pinakamahinang ano eh. Yan ang pinakamahinang correlation, no? Ito, negative 0.05. Practically very weak correlation with hourly wage. The others, si education, si tenure, si experience nga mababa, 0.11. Kaya nga significant lang siya at 0.10%. Okay. Bigay ko lang class yung explanation nitong isang to. This one. What about this? Ano ibig sabihin nitong ano? And then we'll continue with this next time. Race. Bakit nagka-white dito? Let's take a look at our data. Okay, wage. Si race. Okay. Ano nangyari dito? Ang data natin, class, di ba sabi natin, ang levels ng race is, okay, race is white at saka non-white. Okay? White at saka non-white. All right. Now, what R will do is that, syempre hindi niya mariregress to kasi categorical to Iaano niya to, it will, okay, the process called dummify. Ida-dummify niya na. Ano? So I'll explain this in greater detail next time, pero bibigyan ko lang class ng interpretation tong una. No? So, next meeting, sorry, mali. Mag-stop share ako. Next meeting, I'm going to discuss itong result ng ng categorical variables natin. This one. Suffice it to say, class, anong ibig sabihin nito? When we interpret this now, itong race white. So, although itong gender male, kasi itong tingnan natin to, kasi significant siya, no? Si gender male, ano ibig sabihin nito? So, it's now telling us that ito, when you read this, you interpret this in the light of the benchmark variable. The benchmark variable is the variable that does not appear here. The level, which is female. So ano ibig sabihin nito? Ibig sabihin nito, class, I hope you get this, just one minute. On the average, male, okay, male employees get $1.76, positive to, no? $1.76 more than their female counterparts, ceteris paribus. So yan ang ibig sabihin niyan. Okay, for character variable, sinabi niya dito, male, no? So you interpret this in the light, you compare male with a female. So, on the average, male employees get $1.76 more, kasi positive to, than their female counterparts. How about this? Let's assume this is significant. How do you interpret this? On the average, single employees receive $0.46 less. Bakit less? Kasi negative to. Than their whom? Than their married counterparts. Okay? Si single, ang mga andi dito, i-interpret natin siya in relation to, in reference to the one that's not here. Okay, ito, assuming na significant to. On the average, white employees get around $11.11 more than their female, than their non-white counterparts, ceteris paribus. Okay? All right, so let me stop recording now.